welcome to EduPorm EdTech. You're watching expert chemistry lectures with Abhinav Gaur. Today in this video, we are going to talk about abnormal molar mass. Abnormal molar mass. So, in colligative property, we discussed that colligative properties are the properties which are dependent on the number of moles of solute and they are independent of rest of the properties. So, let me give you one example, or I will give you two examples instead of one example. Let's say this is water, and to this water solvent I am adding 1 mole of KCl. So this 1 mole of KCl will give me 1 mole of K positive and 1 mole of Cl negative. That means when I added 1 mole of the solute, that 1 mole gave me 2 moles. Similarly, if I have water and in this water I am adding acetic acid, that means I am adding 1, or I can say I am adding 2 mole. Okay, I am adding 2 moles for better understanding. Okay, I am adding 2 moles of acetic acid, that means CH3COOH. Now when 2 mole of acetic acids are added to the solvent, which is water, then due to hydrogen bonding, the molecules of acetic acid will form dimer, and the dimer will look like this. This is CH3, this is C double bond O of the carbonyl group, and this is O and H of the hydroxyl group. This will form hydrogen bond to the another hydrogen, which is the hydroxyl group hydrogen, and similarly this hydrogen will form hydrogen bond with the oxygen of the carbonyl group, and the molecule will look like this, where we have CH3COOH and CH3COOH. Okay, and they form one dimer, and this dimer is due to the hydrogen bonding. Okay, this is the hydrogen bonding between hydrogen of hydroxyl group and oxygen of carbonyl group. Similarly, this is the hydrogen bonding between hydrogen of the hydroxyl group and oxygen of a carbonyl group. So 2 moles will give me 1 mole of dimer. Okay, 2 moles of acetic acid will give me 1 mole of dimer. So in the first case, the number of moles were increasing, and in the second case, the number of moles were decreasing. And this association and dissociation was resulting in abnormality in the molar mass. Hoff gave a factor called as Hoff factor, which is denoted by I, where I, that means Hoff factor, is equal to the normal molar mass to the normal molar mass divided by the abnormal molar mass. This is also called as the theoretical molar mass, and this is also called as the experimental molar mass. There is one more formula where I, that means Hoff factor, is equal to the observed colligative property, the observed colligative property upon the calculated colligative property. And one more formula is there where I is equal to the total number of moles, total number of moles of particles before association, okay, before association or before dissociation, divided by, in the above side we will have, this is a very minute mistake, from on the above side, on the numerator side, we will have total number of moles of particle after dissociation, while in the denominator we will have total number of moles of particle before association or dissociation. Okay, so these are the three formulas for Van Hoff factor, and this Van Hoff factor is also related to colligative property. So the relation is for del TB is equal to I, that means Van Hoff factor multiplied by KBM. We have already discussed in previous lecture what is delta TB, what is KB, and what is M. Another is del TF is equal to I KFM, and the another formula is delta P upon, sorry, not delta P, we will have P naught is equal to I into X. Okay, X B, or we can say X2. This is for the mole fraction of solute. And for this is for elevation in boiling point, this is depression in freezing point, this is for relative lowering in vapor pressure, and for osmotic pressure it becomes pi is equal to I multiplied by CRT. So these are the four different formulas with respect to Van Hoff factor. Thank you.